Okay, so I'm going to try and do a video here for chemistry for this past week for the first part of chapter 11, and we'll see how it goes, but hopefully it'll be at least some help to everybody. I'm going to start off here with the chalkboard, the information here on the chalkboard. This is stuff from the chapter that you need to memorize. So I'll stay focused on the chalkboard here for a bit. You can get some notes down. Basically, the things that you need to remember from this part of the chapter is, first of all, that acids donate the hydrogen ions and the bases accept them. You also need to memorize that ionic compounds that contain the hydroxide ion can act as bases. Ammonia is a covalent base, and if a covalent compound starts with hydrogen, it usually acts as an acid. In determining if a chemical is an acid or a base, make sure that you watch for these things. We say if it begins with an H, it usually acts as an acid. Remember, there are some exceptions. Those amphoteric chemicals that can act like either an acid or a base. And one example of those that we did quite a bit in the chapter was water, which we all know is H2O. So it starts with an H, but it can be either an acid or a base depending on what it is being combined with. So remember also in a chemical equation where that H comes at the beginning, it also tells you how many hydrogen that particular chemical can donate. For example, if you had H3C6H5O4, you would know that that particular chemical could give up 3 hydrogen. So I had a question from someone about the CCs number 7. So we'll go over CC 6 and 7 because they go together, and then we'll go ahead and go to the chapter review and go through a few of those. So CC number 6, if you look at it, you have HClO3 combined with that NH ammonia ion there that we have on the board. So again, we see this is why it's really important for you guys to memorize these things. So from what we have been looking at memorizing, we're going to be able to tell right away that in number 6, ammonia is our base. The HClO3 follows that hint that it starts with an H, so it's probably an acid. And we can confirm that because it's combined with the ammonia, which is a base. So if you hang on just a minute, I'm going to change the phone. I'm going to use my improvised phone holder to be able to record the paper and make some notes on how things are done on the paper. So I'll get that set up. All right, so with number 6, we're working on CC6. And hang on a second. Technical difficulties. First YouTube video. Bear with me. Hopefully this will work out. Okay, so we had CC number 6. We have HClO3 and NH3. We recognized NH3 as ammonia, our base. So that told us that HClO3 is our acid. We know acids donate their hydrogen and the bases accept the hydrogen. So combining these two is going to produce ClO3 because this unit right here gave up its hydrogen, and NH4 because the ammonia went ahead and accepted it. So that would be the chemical equation. Make sure you remember, this is your acid, which gives up the hydrogen. This is your base, which accepts the hydrogen. If this gives up that positive hydrogen atom, then this is going to have, it's going to have the negative charge, and this will have the positive charge. That's the negative charge. All right, these two ions having opposite charges now is also important because that is what allows the conduction of electricity. All right, so if you did number 6, if you don't have it in front of you, why don't you go ahead and pause the video for a second and look over what you have. Make sure that you had that HClO3 combined with ammonium becomes ClO3 negative and NH4 positive. All right, so we'll go on to number 7. In number 7, we are given H2CO3 and AlOH3. Now right away you should see a couple of hints here. We should see this one begins with hydrogen, which should indicate to you that it is potentially the acid. We should see that this one has the hydroxide ion in it, which we know ionic compounds that contain the hydroxide